Hi, Miss Marion here. Let's go to page 137. Let's read the I can statements for lesson 7. I can write an equation for the relationship between the total volume of a ground-related cylinder and the number of objects added to the ground-related cylinder. And I can use the patterns to write a linear equation to represent a situation. Go ahead and write yourself a sentence on page 137. How you feel about these I can statements. Give yourself a number 1 through 7. 1, I don't remember. 2, I kind of remember it. 3, I remember, but don't ask me to teach it. And then 4, I do remember it, and I can teach it to my friend. So by the end of today, you should be able to create an equation that represents a linear relationship. You should be able to generalize, both in oral and in writing, a method for calculating slope based on coordinates of 2 points. And you should be able to interpret the slope and y-intercept of a graph of a line in context. Let's go ahead and turn to page 61, and we have these 3 cylinders filled with blue water. Which glass will hold the most water, and which one will hold the least? Go ahead and write these sentences on page 61. I believe blank holds the most water because blank, so fill in the blanks, right? And then also write the sentence, I think blank holds the least amount of water because blank. And fill in the blanks with your what you have decided. Go ahead and do that and pause at this moment. All right, let's go ahead and watch this video and see which one holds the most water. So as you can see, the graph A, so the cylinder A is the one that holds the most water. All right, so we're going to talk about water and then putting marbles into water and how it goes. Go ahead and turn to page 61. This is 61 through 63, and we're going to go ahead and we're going to fill up the table that is on page 61 with what we're doing as far as putting marbles into this cylinder. So you're going to watch a video, and you need to go ahead and fill in the table with the number of objects and the volume that's in the milliliters itself. So you might go ahead and have to play that video again, rewind and play the video again to go ahead and fill in the table with all the information. All right, here is the table that you should have filled in as far as on page 62. So at 0, the volume is 60, at 1 is 63, at 2 is 66, at 3 is 69, and at 4 is 72. So let's go ahead and let's answer number 2. What is the volume V in the cylinder after you add X objects? So where did we start? We started at 60 milliliters. And then what happened with every object that went in there? So it added, if you look at it, it added 3 milliliters. So we're going to do 3 milliliters for every X object that happens. And this is our volume that's in the cylinder overall. Number 4 says, if you want to make the water reach the highest mark on the cylinder, how many objects would you need? So we have 100 milliliters in our cylinder. So how many objects are we going to go ahead and need? Go ahead and figure that out, and we'll go from there. So we are going to need about 13 objects or 13 marbles to go into the cylinder, so that doesn't overflow it. There will be some room that's left over, but we're going to need 13. How did I figure that out? Well, I know that there's 100 milliliters total in the cylinder. And that is the total amount of volume. So I'm going to go ahead and I'm going to put it into the volume area of number 2. So I'm going to say 100 equals 60 plus 3x. And so I need to go ahead and figure out how many I can go ahead and put in there. So I can either extend out my table and I can go ahead and figure that out, or I can kind of play with it itself. If I put 13 into this equation, so if I do 60 plus 3 times 13, so that's times, this will end up being 99 milliliters. If I do 14, then it's going to go over the cylinder and it's going to get rid of our water. So go ahead and take those points and plot them on the graph, and then make a line at it. They should actually make a line, so go ahead and pause it this time and make your graph. All right, so you should have something kind of like this as far as your line. And so notice how we did 0 is 60, 1 is about 63, 2 is 66, 3 is 69, 4 is 72. All right, let's go ahead and answer number 6. Commute the slope of the line, and then what does it mean in this situation? So go ahead and pause and find that slope. So personally, what I'm going to do is I'm going to pick 2 of the points that are on the graph and go ahead and kind of solve it. So I'm going to pick the point 1,63 and then 2,66. All right, notice how I made a right triangle with my 2 points. I'm going to go ahead and I'm going to find my vertical. How do we do that? We're going to subtract the 2. We're going to say 66 minus 63. That is 3. And then the horizontal, we're going to say 2 minus 1, which is 1. So the slope is 3 over 1. But we need to go ahead and we need to label it. So what is the vertical? So we, as far as labeling it, we're going to pull it from the vertical on our graph, or the Y part, and that's volume in milliliters. So we're going to say milliliters. Okay. And then what is the horizontal? Again, those pull from the bottom. That's number of objects. So we're going to say objects, 1 object. So what does this actually mean as far as the slope? So it's 3 over 1, so it's 3 milliliters per 1 object. What does that actually mean? That means every time we add 1 object into our cylinder of water, it adds 3 milliliters to the overall volume of that cylinder. All right, next we're going to go ahead and do number 7. What is the vertical intercept, and what does it mean in this situation or in this story? So go ahead and pause and figure out what that is. So remember, the vertical intercept comes from the vertical axis, the y-axis, and it starts at 60. So the vertical intercept is 60, and what does that mean? Well, our cylinder started at 16 milliliters. That's how much water it had at the beginning before we added the objects into, the marbles, into the water. All right, on page 64, let's do Are You Ready for More? A situation is represented by the equation 5 equals 1/2 x. 1, invent a story for the situation. 2, graph the equation. And then what does 1/2 and 5 represent in your situation? And where do you see the 1/2 and the 5 on the graph? So go ahead and pause right now. Go ahead and make your story and then do your graph. All right, here is mine. My story is Don has 5 pounds of apples in his box. He added 1 pound of apples per 2 minutes into his box until it was full. As you can see, I have my graph here. So it starts at 5. And then for every pound of apples, it takes 2 minutes to go ahead and go in it. And so you can see the 5 here. And then we can make a slope triangle. So 1 over 2 as far as our slope. And so for every pound that he puts into his box, it takes 2 minutes to go ahead and do that. All right, turn to page 64. You're going to go ahead and calculate the slopes for all of these slope triangles. And remember how we do our vertical over horizontal and how we go ahead and figure those out. So pause right now, figure out what those slopes are. All right, let's go ahead and find those slopes. So remember, on A, we were going to find our vertical and then our horizontal. To find our vertical, we're going to go ahead and do 9 minus 3. So what is 9 minus 3? That is 6, because we're going to subtract our x values. For our horizontal, we're going to say 4 minus 1. 4 minus 1 is 3. So the slope is 6 over 3. And is that a skinny or fat fraction? We need to reduce it down. And we also need to put it as a fraction. So if we do 6 over 3 and we put it in our calculator, we're going to get 2 over 1. And that is our slope. Let's go ahead and go over B. So again, we are going to take our verticals. We're going to say 3.5 minus 1.5. So do 3.5 minus 1.5, and it is 2. And then we're going to say 10 minus 2. What is 10 minus 2? That is 8. So our slope is 2 over 8, because remember it's our vertical over our horizontal. Can this be reduced down? Well, hey, let's put it in our calculator. Tell it to simplify. And yes, it can simplify down to 1 over 4. Let's go ahead and go through C. So C is 75 minus 35. 75 minus 35, put it in your calculator, press enter, we're going to get 40. And then we're going to subtract our x's, that's our horizontal. We're going to say 30 minus 10. 30 minus 10 is 20. So we're going to have 40 over 20. So is this a skinny or fat fraction? That is a fat fraction. It can be reduced down to 2 over 1. So these are our slopes with the triangles that we have on the lines. So remember what we're doing today is we're looking at our slope triangles. We're looking at our slopes, right? We're also looking at our vertical intercept. That's where the line crosses the vertical axis or the y-axis. And so this one would be 10, and it would be 10 liters of water. And then our slope, we're going to go up 10 and over 5. So up 10 and over 5 can reduce down to 2 over 1. So it has it. So then our horizontal is minutes, so number of minutes. So it's going to be 2 liters of water over 1 minute. All right, so let's go back to page 137, and let's make a sentence about our I can statements. I can write an equation of a relationship between the total volume in a granulated cylinder and the number of objects added to the granulated cylinder. And then I can use patterns to a linear equation to represent this situation, and give yourself a number. So 1, I get it, or no, 1, I'm confused. 2, I kind of got it. 3, I got it, but then 4, I can teach it to my friend.